So, what's the paper about?
Yeah, so we were just talking about it before. So at least I would look at it like from a quite general point of view, in that what scientists, and particular material scientists and us as materials physicists, what we like to do is control material properties and influence the way that materials behave at their electronic level. And the idea with this paper, or with this project in general, was to use purely mechanical means to control electronic properties.
What kind of electronic properties do you control?
Well, so that's maybe the point first is like what are the possible electronic properties we're talking about? I have in mind mostly phase transition. For example, in our work, we often look at materials which change between an insulator and a metal. So something which conducts electricity and something which doesn't.
And you said that you used mechanical means. Can you tell me more about that? What does that mean?
So yeah, this is the possibility to apply strain to the material, like normally you would stretch or compress or bend something, you induce strain in the material. This is the way that you can affect the mechanical properties of the material, which in turn change the electronic behavior.
So why does bending or pressing something change electronic behavior? They sound like they're on very different levels to me.
That's a good question, Lucia.
Yeah.
Well, one of the things that we often find is that things are strongly related to each other. So even though they seem to be quite disparate, there is in fact a strong relation. And if you want to have a kind of intuitive picture of that, you can think of your solid as being built of atoms, which are little balls arranged in some periodic manner. And between those atoms you have a little stick, which is your bond. So that's what's holding the solids together. And as you can imagine that pulling your material or squashing your material or bending your material is going to change the way that those bonds form and change the way that the atoms talk to each other. And since the bonds themselves are formed through the electrons, it's the electronic properties that you're going to change by doing these kind of bending or distortion motions.
So you're applying this strain, you're bending things and compressing them, and how do you actually do that? I bet you don't use a hammer and a spanner, right?
We don't. We do use a screwdriver. So there are different possible ways to do it, and the one we do is almost the simplest you could think of. So what we do is we take our sample and we glue it on a little copper bridge piece, and then underneath that copper bridge is another block which is slightly too large compared to the size of the bridge legs. So when we screw the bridge legs down, it forces this copper piece to bend, and if our sample is glued on top of that, it also forces the sample to bend. And in that way we're able to induce some small amount of strain into our sample.
And Aki, you're a theorist, so I guess you don't have to glue things to copper bridges, but rather model these strain effects. So how do you do that?
Yes, on a computer we can decide where we put the atoms and how we arrange them. So we have a lot of control how we apply the strain and how we distort the material.
So you have like a program that simulates the material and you apply forces to very specific parts of it in the program?
Yes, that's a possibility, yes.
So you mentioned in your abstract that this application of strain to control these electronic and structural properties is a pretty new idea. Is that because it's very technically difficult, or is it just that people didn't think of it until recently?
Oh yeah, that's a good point. Okay, so the idea is absolutely not new. It's been around for quite a while. And of course it's quite a simple idea, so it makes sense that it has been around for a while. What's a bit newer, we could say, is the type of materials that we know about and understand. And people have only really started looking at these what we call correlated materials, also these 2D materials in detail in quite recent years. when we said in the abstract that it was still in its infancy, what we had in mind was that the application of these strain methods to complex materials is still quite new, and particularly being able to control material behaviors in a specific way.
Of course, when you find new things in materials physics, you get new things that you might try to control with strain. So you might want to, the
Excellent.
previous Chris's comment, that bring these new phenomena or strengthen these new phenomena by applying strain.
So what's the relationship like in your group between experiment and theory? Does theory inform experiment and kind of tell it what to go and do? Or do the experimentalists tell the theorist what you'd like them to model, or both?
Yeah, so I mean, this goes both ways, and it depends on which part of the project we're in. I would say in this case, we started from the experiment. We had an idea, we had a material, we tried it out and we got some results, which we then wanted to understand. We went to Aki and asked him if he could do some calculations and help us to understand our experiments. But now that we're further into the project, Aki is coming to us and saying, well, okay, from my calculations I would expect this, or maybe we could do this, and asking us as experimentalists to push ourselves and go on. So.
Do you ever get sort of unexpected discrepancy between your models and their experiments? Things that surprised you or that you couldn't have explained in your model?
Sometimes there are things that don't agree really well, but then it's mostly refining the calculations from my side.
So adding in more detail?
Yeah, that's true.
Well, one thing that also came out nicely with this project was with our experiments we tend to look at specific bits of the possible information, and with the calculations you can look at the kind of wider view of everything at once, and actually you notice some effects that we hadn't seen in the experiment. I would say that was a really nice outcome of this project, was that your theory was able to tell us as experimentalists, you should look here, and that's something we're still trying to do.
Working hours, like, do you have a good work-life balance as a lab physicist?
So this is something that depends a lot. I would say the big challenge with a lab is getting everything working all at once. So once you're in that situation where your manipulator is manipulating, your sample is there and it's ready, your light source, your laser is working well, for all that to come together is a big effort. And so once you have it, you really don't want to stop until you say, okay, we've got it. We've got everything we need and we're happy. So that does tend to lead to situations where you can be there for quite a long time.
And so, is it fair to say that whatever experiment you might be doing at a given time, one of the main challenges is just kind of maintaining your lab?
Yeah, lab maintenance is a big part of what we do, and you can imagine, I mean, these high vacuum environments, they're very isolated from the outside world, so we can put little things that allow us to move samples around inside the vacuum. We have manipulators which do a lot of this. You can imagine it a bit like working in space, I guess. So you imagine these guys dressed up in their suits and trying to manipulate something, slowly and carefully, and it's a bit like that, except that our suit is the chamber itself, so we're outside looking in, and everything is very delicate and things can go wrong, of course, so we have to maintain regularly.
The difficulty maybe is that I carry the lab with me, so I always have the access to the calculations, and sometimes it means that the work and free time kind of mix. So I might start my day by taking my morning coffee and already looking at the calculations that have finished during the night. Maybe I have to restart some calculations, and then I go to work and analyze the ready results, and hopefully in the evening I don't have to look at the calculations anymore, but yeah, it's different.
Aki, do you also get to go and play in the lab sometimes, or are you banned?
Powder effect.
Yeah, I have been in the lab Yeah, mostly my work is done on the computer, so I just have some requests maybe for the experimental side so that the other people who have more experience with these kind of things, they can maybe try things out. So.
But I mean, you did participate in some experiments.
Yeah, I did.
once,
Yeah.
But I mean, I never look at Aki's code.
I know.
I mean, that would seem like an exercise in pointlessness.
Okay, interesting.
Constant struggle, indeed. Yes, the vacuum struggle is real.
Yeah, for me, the vacuum comes naturally. So if I want to have air in the calculation, I have to add it.
So if you can imagine, like with a stick, if I would stretch it, then it would become a bit longer.
That
would
can
be
happen
strain.
if you apply too much strain.
Too much strain. But also if I would compress it, I mean you can't really see it, but if I push it together, then it also breaks. That's why we don't do our experiments on sticks.